agile and quick. Okay, so let's start. So what are we going to talk today? Today we're going to talk first about the background of Kubernetes secrets and try to understand how exactly does it work, when do we really need it, why does it exist, and by understanding how does it work, we will be able to investigate further about the security concerns when you're using Kubernetes secrets. We'll find out that Kubernetes secrets is, despite its name, was not necessarily made for the purpose of security rather than interoperability. I'll dive into that. That's not a problem. Anyway, but we'll talk about how to mitigate those security concerns. And then we're going to talk about something very special about zero trust / privileged access for Kubernetes, something that at least we found that is in most places, it is left neglected in terms of who can access my Kubernetes secret. Maybe because the ones that actually care about Kubernetes are the admins themselves. So we need to make sure that the admins themselves are who they are and who they are saying that they are by using all kind of mechanisms. We'll talk about that. And then we're going to talk about concept of just-in-time secrets. What does it mean? How does it help us with protecting those secrets? Okay, let's start. So first of all, what is a secret? Secret can be API key, passwords, token, sometimes even encryption key. Basically, every object that is being used in order to authenticate and authorize, sometimes even for encryption targets. Any object that is used to authenticate and authorize within our environment. Now, most times it is quite acceptable to say that secrets in that term are for machine to machine, but not just machine to machine. So the passwords that you are using or the certificate that you are using when you are authenticating to Kubernetes is also a secret. For now, for the time being, when we talk about Kubernetes secrets, those are the secrets that would be used within the containers that are running on top of Kubernetes. So we will focus about the machine-to-machine secrets. Now, secrets can be either hard-coded within the application code, within the container code itself. They can also be on the configuration file, inside some environment variable that you're using within the application code. So this is, those are the places where we'll find those passwords. By the way, one of the most famous use case for secret is a connection to the database, right? You have a password, your container needs to access a certain database, and then you need the password and the connection string in order to authenticate to that database. So where do you put that secret? Where is it? Is it hard-coded? Is it within a configuration file and whatever? So the question that always has, that you have whenever you have a container, should I put those secrets within the container itself? And it means that within the image, you'll have within the image file of the container, you'll have a username, password, and a connection string to a certain database. Now, what happened if the password itself requires rotation? You need to reuse a new image. What happens if a developer or any other DevOps engineers can see those passwords and credentials to the database? Basically, it means when you keep it within the image of the container, it means that those secrets are exposed to any external threat, either if it's machines or by any human threat that can actually grab those secrets outside. So Kubernetes secrets, and this is where it comes into the discussion. Kubernetes secrets, the main goal is basically to provide decoupling of the secrets from the application itself. And the reason, and I'll go back. So here you can see that those secrets are within the container, Now, the whole idea of Kubernetes is basically to provide virtualization of the running operating system, okay, the running platform. So the whole thing here is to first provide some kind of a mechanism to decouple the secret from the application itself, and to, of course, reuse the secrets for within a cluster for several applications. So the thing is that if you're looking at it, and we'll talk about it, you might find it not necessarily secure. And I know it sounds a little bit weird, but now we're going to talk about it. So first, let's understand how Kubernetes secrets work. So here, as you can see on a certain node, and we have two pods, just as an example, pod X and pod Y. Now, instead of having the secrets themselves to be within the container image, Kubernetes allows you to basically say within the application that is running that you are trusting someone to provide you with the secrets within session variables, environment variables, virtual files within the container or the pod, and so on. So Kubernetes secrets would be able to hold and store your secrets within etcd database, okay, which is a key value database that is used within the Kubernetes management. And whenever a pod is going live, then, or a container for that sense, then within the YAML file, you are being able to ask for a certain secret to be pulled and to be accessed while the container is running, again, via virtual files or within an environment variable. So the whole point of Kubernetes secret is a mechanism, again, to provide those secrets whenever the container is running, and to keep the containers free of those secrets, not to have configuration files within the container, not to have those secrets within the application code, and so on and so forth. So that's the major thing about it. It's to decouple those secrets and to put it out. Now, the number one problem within that story is that etcd isn't quite a encrypted database. etcd is, let's say that those secrets inside, they are base 64 encoded. Base 64, as you may know, is not an encryption technology. Base 64 is merely an encoding method. So it means that within your YAML files and within the etcd database, those secrets are quite open. It basically means that they are in clear text within your Kubernetes cluster, okay? So in order to mitigate that problem, first of all, you need to enable encryption at rest for specifically within the etcd database. By the way, later on, I would be able to provide you this slideshow, and happily you'll be able to have the links down here that you'll be able to follow in order to enable all kind of systems, all kind of features within Kubernetes in order to make sure that the database is encrypted. Now, more than this, and I'll speak about it in a minute, but you need to limit access to etcd for Adbit users only. So you need to make sure that the etcd database is quite protected in terms of access, and not just to assume that no one would access it privately, specifically for that sense. Now, more than this, you'll need to enable TLS and SSL between the etcd and your pods. It means that encryption at traffic and transit, and not just encryption at rest. Of course, when you're changing clusters, when you're taking your pods off, you need to wipe disks and so on. And your YAML files eventually will still contain the base 64 secrets. So don't ever share them or check them in a certain repository. So that's just the start, and that's the bad news about what I'm saying right now, because you might think that this is all okay. So I'll have a day or two or three to configure all the things that I see here. Some say that it's quick, some say that it's not that quick, but the real problem is that that's not really the whole thing. Secrets are still exposed after they are also encrypted, And the reason is because the architecture of Kubernetes secrets basically allows to read decrypted secrets within any container on a particular pod. So imagine that you have a pod, and quite honestly, the problem is even deeper than that, because whenever you have Kubernetes secrets to hold those kind of passwords and API keys, then every pod can declare that they wish to get within the YAML file that they wish to get a certain secret. Now, the bad truth behind all this is that there is no identity and access mechanisms that says that a certain pod would be able to access a certain secrets. So since it's all declarative and it's all configuration by code, then only thing that you need is just to have a certain pod YAML file to just specifically say that they are interested with another secret, and they would be able to pull it away, decrypt it, and do it whatever they want. So it's not just the fact of encrypting the secrets themselves at rest or at transit. It's also that you need to take care of the fact and to make sure that you know that all of your pods will be able to access the secrets. So you try not to have two pods of two different applications, otherwise you are exposing secrets within non-related pods, okay? So in terms of mitigating it, you can see that by Kubernetes concept, the basic concept is saying, okay, so run one container per one pod, and if you really want to make sure that no one can see your secret, then have maybe even one pod on a certain cluster, and that's nonsense. No one really runs one pod on one cluster. That's not the whole point. So the real option, which is option 2, is that for you to consider a secrets management solution that supports namespace isolation or container isolation, that you'll be able to basically inject those secrets directly to that container, and to be able to say that only a certain namespace would be able to see a certain secrets, okay? Obviously, with Akeyless, this is something that we support, and this is something that we are warmly recommending. Okay, so let's say that encryption is there and you're about to use a secrets management solution that will allow you to have namespace isolation, which is very good because this is how you'll protect those secrets. Now, what you need to make sure is that the administrators of your Kubernetes clusters, they are who they are. So it means to better identify them. And to zero trust the kubectl access, that basically this is it. And number 2, after that you have found that this is, they are who they are using multi-factor authentication, this is where you need to make sure that they are using short-lived certificates. So let's go like this. The default of accessing kubectl is by having, or the kubectl is creating for you a short and long-lived certificate. Long-lived TLS certificate basically means that whenever you're getting that certificate and you are using it in order to authenticate to kubectl, then it means that if someone is grabbing your certificate, you won't necessarily know about it, obviously. And when you don't really necessarily know about the theft of the identity, then you won't really know, or you won't really be triggered to change that certificate or to revoke that certificate. Okay, so whenever you're using a long-lived certificate, and that's the case for any just-in-time access, and I'll talk about that in a minute, but basically the best practice is to use short-lived access. So every time that I'm interconnecting, every time that I'm using kubectl, then magically I would want to have short-lived certificate for that specific session. Why is that good? Because next time that I'm running a session, then I'll be using a new certificate. And if someone grabs my certificate of that session, they would be limited to the period of time that the certificate is valid for. So this basically protects us from identity theft or certificate theft. So here, to summarize, we're talking about two things, and here I'll go about, and I'll talk about the third one, and it's all related to the privileged access of the Kubectl. So number one, Kubectl, everyone that is using Kubectl is able to see your secrets. Okay, now you do not necessarily want every administrators on your Kubernetes cluster to be able to see all the passwords, and not even you. If you are the administrators of the Kubernetes cluster, then obviously you should not be able to see the secrets of the application, the access to the database, because it's a strong access, okay? So one, you need to make sure that administrators are who they are, how to do that with MFA. You can basically interconnect Kubectl with multi-factor authentication to enforce multi-factor authentication, as you can see, by interconnecting Kubectl to an external identity provider. Kubectl has some XAML support, and with that, you're being able to interconnect it with Okta and any other XAML or OpenID identity providers. So that's one. Second, the access itself should be restricted to short-lived certificate, and you need to use some kind of mechanism that will create that short-lived certificate. Obviously, Akeyless supported, and I'll be able to talk about it offline whenever you want, and even to demonstrate it. But basically, short-lived certificate, this is the place for you to mitigate that problem. Now, number three, in a highly regulated environment, you would also want to audit any Kubectl command. So if there are 3 administrators, 4 or 5 administrators to a certain Kubernetes cluster, you have the ability to also record their commands. And later on, for security checks and audit, you'll be able to see exactly who has done what in the history log. So this is this is an area, the Kubectl privileged access that we found. We find that is most times is neglected. So please remember that even when everything is encrypted and you already interconnected with secrets management system, the Kubectl administration access is important. Great. So Kubernetes secrets, this is where Kubernetes secrets might not solve. And we all need to remember that even after everything is encrypted and your secrets are encrypted and you've enabled that and you're having a strong permissions and strong short-lived access and MFA to your Kubectl and so on, you've hardened your Kubernetes. The real problem here is that the application themselves, they tend to use logs and monitoring systems in order to, whenever there is any problem, they're using those to basically report on any variables that they're using. Part of the variables that they're using is the connection to the database. So after all of that, all of those solutions that you've been using, the application itself on the container itself, on every error, would basically write down to the log and the monitoring systems the username and the password that they're using, okay? And this is why we're recommending to use just-in-time secrets. And so let me elaborate about that in a minute. And the number two, another problem that you need to face is that Kubernetes secrets might protect you within the Kubernetes, or working with protecting the secrets within the Kubernetes environment might help you for Kubernetes. But what about all the other DevOps tools that are using secrets? Okay, not all of those tools are better working with protecting those secrets. And even that, you'll have some operational problems when you need to replicate maybe secrets within numerous tools. So this is another recommendation, to use a unified solution for secrets that will be able to sync all of your secrets between all of your DevOps tools using plugins and so on and so forth. So going back to just-in-time access, let's talk about that, because just-in-time secrets, this is the ultimate solution for how to protecting your secrets. And just-in-time basically means on demand and temporary. Just-in-time is like a combination between on-demand secret and a temporary one. So let's talk about that. So we talked about the least privileges approach and the short-lived idea. But let's combine them together. And let's take an example for like a bank account. Whenever you're authenticating to your bank account on your website, on the bank website, and this is basically where banks tend to create for you a one-time password. Okay, so they have some kind of a broker there. They identify you on the website itself, and then they're saying, okay, the password for that particular session would be the number XYZ. And this is where you're getting some kind of a one-time password for that specific session. Now, the same concept can happen with your containers when they wish to access a database or whatever resource or whatever secret that they require. So how does it work? So imagine that the container goes up and then it asks for secrets for the database, password to the database or password for whatever resource that they wish to access. Now, instead of getting a static secret, the container would ask for a dynamic secret, for a just-in-time secret. And this is where the secret management system would create credential on demand, would actually create an account on the database right as the container goes up. And a new temporary account would be created specifically for the time of the life being of the container itself. So whenever a container goes up, at the same time, a new credential, a new account of the database is being created, and the container is using a temporary user every time that it lives. Now, what we're getting out of it is that no matter if someone saw the secret itself, even if the secret was written by the application directly to the log or monitoring system, and B, if any malicious attacker was able to attack the system and to grab the credentials within the memory, then after the container is down, and everything is ephemeral in our environment, in the Kubernetes environment, then the bottom line is that they would not be able to do anything with it because the credentials of the database are temporary and will be revoked after the container is down. Okay, so basically, just-in-time secret, you can say that it is fully correlated with the ephemeral nature of the Kubernetes environment. So since Kubernetes containers goes up and down, they live and they die, then the same needs to happen with your secrets. Every one of your secrets need to be created specifically for the container and to be off and neutralized and revoked whenever the container is down. And this is where you can completely, let's say, feel safe when you're working with secrets. So that's a little more work, but you'll gain maximum security by that. So the recommendation for you regarding secrets management solutions is to find the one that would provide you plugins to whatever DevOps tools that you're using. So you need the variety of plugins because tomorrow you're using Jenkins and later on you're using Circle CI and lots of others. So you want to have plugins through all your DevOps pipeline. Number two, find the secrets management solution that obviously support just-in-time secrets, both for humans and for machines. And for humans, we talked about specifically the short-lived certificates. So your certificate management solution would need to be a certificate authority and to be able to issue short-lived certificate, and of course to provide you with external recording to the Kubectl session, and also the ability to interconnect the Kubectl to whatever identity provider that you're using, either Okta, G Suite, Azure Active Directory, whatever that you're using, then the identity provider should be interconnected using the secret management solution that you're using in order to enable the multi-factor authentication. I think that by that was 25 minutes. I believe, Chuck, that we're on the clock.
Hey, that's pretty good. That's pretty good. I'm very happy with that. I
Okay.
think we've got a question in the audience already. Daryl, did you have something you want to talk about? Daryl, if you're talking, you're muted. No? Okay. All right. So okay. So I'm going to go ahead and launch a poll while we're here talking about the Q&A. So I do have a question for you, Oded, to kind of kick things off. Is there a difference in your mind between a temporary token and a just-in-time secret? Are these kind of the same thing?
A temporary token is, yes, it is quite, you can say that it is a just-in-time secret, but it depends for what, for who's creating that temporary token. In what scenario are you referring to? If you can elaborate about that.
Well, so an architecture that I've used before, especially in cloud, is when I have, say, a role that grants me some permissions. Like, let's say that role allows me to promote somebody to administrator, for example, right? It's a pretty powerful role. So I want to have that secured in a secrets manager. And so instead of giving GitLab that role directly, where it's stored in, in a CI/CD variable, what I would do is I would store it in a secrets manager and then use an authentication method in GitLab to fetch a token on that credential rather than to fetch the credential itself. Does that make sense?
Yeah, exactly. You got it right. The whole point is to use, in terms of authentication, to use the identity of the one that is asking for a certain secret, okay? The strong identity, which is the cloud identity, okay? By the way, what happens when you're not on the cloud, when that resource is on a private cloud, you need a machine identity of your own, okay? That's a good point that we can talk later, by the way. But the whole concept is this: to use the machine identity in order to fetch a, let's say, short-lived secret, short-lived certificate, short-lived token, and for that machine to use that short-lived token and to make sure that it expires after a certain amount of time, no matter if it's 5 minutes, 2 days, whatever, as long as it is short-lived and expired. So yes, we're talking about the same thing.
Right, 2 days, 2 months, as long as it's not a permanent token, right?
Yeah. As long as it's not permanent, that's the whole story about it.
Yeah, Kubernetes has some really interesting challenges around secrets management, a couple of which I was aware before we came here, but definitely you've opened my eyes on some things. So Daniel has a question for you. Daniel says, why not querying secrets from containers directly using secrets from cloud containers like AWS? This can be done via a service account, which is granted an AWS role, for example. In other words, just bypass Kate's secret entirely.
Okay, that's a very good question. So, and please correct me if I'm wrong, but the question is about why not having the application code itself to query for those secrets and bypassing all the mechanism of Kubernetes secrets. Basically, it means that you need to use some SDK in order to do that within your application code. Am I right? That's the whole thing about it. So when you are working with an SDK, then yes, of course, this is the highly secure way to do so. In terms of AWS, I would like to refer to that. Although, of course, there is a solution, Secret Manager within AWS, but the problem starts whenever you're having an hybrid environment. If you have an on-prem and also, or you have your own legacy, plus you have a cloud provider. And this is where you need to ask yourselves, does one single cloud provider can provide me a solution for my entire workload? Okay, because it's nice. If you're working on your own cloud native environment and you are not into legacy environment and you have your own and it's one single region, that's fine. But mostly the solutions of the cloud service providers, they support their internal systems. So it means that if you have if you have your, let's say you have all kind of DevOps tool on within your AWS environment, then you'll need to work really hard in order to interconnect them with your CI/CD, to interconnect your AWS Secret Manager to your CI/CD pipeline, to each one of your configuration management systems and so on. Not all of them have plugins because, again, it's a walled garden approach. So their main mission within the cloud service providers is within their secrets management and the key vault solutions is to provide a solution for their internal systems. That's important to remember. Number two, when you're working with a multi-region environment, then you'll need to replicate those secrets within the secret manager to replicate between regions. Then remember that. So it's all a matter of scale, right? If you're doing like a project with a one single region, then you're fine. Whenever you will start to scale, you will start to tackle the real problems of, okay, how do I get my secret in Edinburgh and also in Stuttgart, and also I'm getting the same secret that I need to use in my US East and US West. So this was where things getting complicated. But to your question, SDK is always better to use and to have it directly to the memory of the application itself.
Cool. Well, so we still have we have the Q&A tool open. If you're not familiar with how Zoom Q&A's tool worked, right there by the chat field, you should see chat, share screen, and then Q&A. So if you guys do have questions, please use the Q&A tool to toss them in. Also, if you'd like to ask a question directly over your mic, you can just raise your hand, and then I'll pass the microphone to you.
By the way, did you know, Chuck, that I cannot vote in that poll?
Oh, really? Well,
yeah,
that's probably a good thing.
It says that the host and the panelists and their family members cannot vote. So I cannot join that.
Hopefully your vote would be a good one. I think I could probably count it.
Well, that's what I wanted. I wanted to vote for good things, but I cannot, so I'm sorry.
Girish has a question for you. Girish would like to know, how does your product, Akeyless, compare with HashiCorp Vault?
Oh, that's a great question that I always like. So the bottom line is that we're better, we're faster to onboard, and we're cheaper. That's the bottom line. So now let's talk about that. So in terms of compatibility, we're incompatible with every feature that they have. That's one. Number two, we're more comprehensive. We have a full solution for zero trust access and privileged access. So, and I'll give an example. In HashiCorp Vault, you are able to create SSH certificate, but you'll need to work very hard and to develop on your own an end-to-end SSH solution that would allow you to completely eliminate the SSH keys. With our solution, we're able to provide an end-to-end solution for zero trust access. It means that every one of your SSH access would be using an ephemeral short-lived certificate. We're supporting session recording. We're supporting real-time revocation of sessions. RDP Kubectl end-to-end solution, as I've mentioned here, with interconnecting with the external identity provider, working with short-lived certificate. All of those solutions, you need to work very hard in order to have it within your vault. And there are all kind of others features like web access and injection of secrets directly to your web access in the human environment and so on. So that's two. Number three, SaaS. HashiCorp Vault, you need to work very, very hard in order to deploy. And of course, yes, you can deploy the playground, whatever they're using, in order to, when you're downloading their first Vault, and yes, you can have it up and running with 5 minutes. But ask yourself, what's the amount of work that you need in order to have it for production grade, in enterprise grade, okay? So this is where you need to invest a lot of time, a lot of knowledge in order to have it running multi-cloud / multi-region, okay, with replication and so on. And so with us, it's SaaS. It means that basically you're going to Akeyless.io, going to sign up, just sign up there. Boom, you're getting a globally available service. We are running the multi-regions for you, multi-clouds for you, and you can enjoy it. Number three, on top of that, it's not just having that SaaS, that's great. It's the pricing, okay? So maybe today you're using open source, but tomorrow you'll need support. An enterprise environment require that support. And this is where you need to basically pay for each cluster that you are using. An enterprise version of Vault, I don't know if you're familiar with their pricing model, but I'll let you ask them and you'll find out that it's very much expensive. This is quite known in the market. Where with Akeyless, it's pay as you go. It's very easy. You can just go ahead and visit akeyless.io/pricing and to better see that it's quite very easy to start working with us, to include also a full free version. Number four, and that's just for now because I can continue about that all night long. And in my time zone, it's night, but I can really continue about that. So the last thing, and maybe the most important part. So with Akeyless, we are using an innovative encryption keys management that allows us basically to manage secrets without having the ability to decrypt them. I know it sounds like something that contradicts itself, but let me explain that. So we have the ability, we have invented an ability to perform cryptographic operations using fragments of encryption keys without ever combining them. This is completely different from Shamil secret sharing. And it means that your fragments of your keys are distributed between different regions and sometimes even between cloud providers. And we never combining those fragments whenever we're using it. So we're providing you with plugins and SDKs to your internal environment. And those SDKs and plugins never downloads those fragments, and those fragments are kept as they are. In a certain combination and a certain configuration of those, we are allowing you to also have a key fragment of your own on your own environment. So it means that we, as a service provider, Akeyless, have zero visibility to your encryption keys and to your secrets. So you are protected from Cloud Act, you are protected from any malicious activity, either external or internal. We do not have any access to your secrets. So it's already FIPS 140-2 certified. We are the only current secrets management solution out there that is FIPS 140-2 certified. And I'm not talking about being compliant, rather than certified and verified by the NIST. So we are already there. So I think that's the answer. If you want to hear more, I have more and more differences. There are major differentiators between our service and what we provide. By the way, we also provide on-prem version with a soft appliance that is very much easier to deploy than the Vault OSS or the enterprise one.
Wow, that's fantastic. I don't think I've ever heard of partial secrets management before. That sounds exciting. I'd like to learn more about that.
Yeah, you're most welcome.
Oh yeah, so Fethia, you've raised your hand. Did you want to speak? Fethia, if you're trying to speak, you're muted. Okay, well, while we wait to see if Fethia wants to speak, Ajit has asked if we have time for a quick demo. I don't believe, Oded, that we have time for a demo, but maybe you and Ajit could coordinate and maybe get a demo of your product.
No problem.
I think that'd be useful.
No problem. Just
okay.
Let me know.
Yeah, if Ajit, if you'd like to get in touch with Oded, you can always email us at chicago@csnp.org, and we'll make sure to get you guys connected. Let's see. So Douglas has a question for us. Douglas says, key management is usually a game of moving the goalpost. For just-in-time secrets, the system will still need database credentials to create new just-in-time credentials, for example. How are those protected? I think what he means is if you're creating a secret, then you're just creating a secret to access another secret, and it's not actually any more secure, because if you compromise one, then you have the other.
This is a very good question, because it involves the problem of secret zero. The secret zero problem is you always need a secret in order to create another secret. You always need a secret in order to fetch a secret. So let's answer it like this. And while I'm doing so, I'm just showing around some of the system, but I'll go here and I'll have my email on the screen. So whoever wants to schedule a demo, whatever is most invited to use my email here. So let's go back. So secret zero. Now, in terms of having a root access, that's true. And the root access to the database would be able to be encrypted also. Okay, so for instance, what we provide is an internal producer within your internal environment. It's like a stateless Docker container that you're running, and you will provide that container the credentials to create other secrets. Now, as a service, we do not see that credential, and we're allowing you to encrypt that credentials. We would do that for you. And to remind you, the secrets, that root access to the database would be encrypted in a way that we cannot access. So that's one, it is being protected and encrypted just like other secrets in a way that there is no vendor compromise option. Okay, so that's one. Number two, and that's the more about the concept of secret zero. Now, if you remember, when we talked about having a cloud identity to fetch secrets, this is where you can have your identities, right? You're saying Azure identity or AWS IAM role, okay? So that particular identity will be able to fetch secrets. It means that you don't really need a secret in your container in order to get another secret because you're using an identity that is provided by the cloud provider. Now, what happens on legacy environment? What happens in private clouds where you don't really have identity management? Private cloud, when you are running your own OpenShift and Kubernetes, okay? Or either if you're using still virtual machines on your legacy environment, you don't have that IAM capabilities of the cloud service providers. This is where, by the way, we are providing, Akeyless is providing what is called Akeyless Universal Identity. It's a plugin. It's totally agnostic to the operating system, whether it's Linux, or, Windows, or whatever. It's even agnostic to the hardware. And it's not intrusive, by the way. And we are providing the machine with an identity that would allow it to fetch secrets, while that particular identity is protected from theft. Okay, now how is it protected from theft? What kind of magic do we have that we're protecting that particular identity? Well, it all goes down to the way that we are managing it. So without getting too deep into our IP, I can say that we are using a how we call replaceable tokens or rotated token. It's kind of homage to Kerberos protocol, where you've had those token rotated all the time. So we're investing our resources in order to discover if there are two components at the same network that are using the same token, and this is where it means that someone grabs a certain token that it should not use. Okay, so I hope that this is clear, and if not, I'll be happy to go offline and to demonstrate that. But we have solutions specifically for that secret zero problem called Akeyless Universal Identity based on rotated tokens.
Fantastic, fantastic. That's really cool. I like that.
Anytime.
Would you mind telling, while we wait for some more questions from the audience, would you mind kind of breaking down a little bit technically how a partial secret works? I'm really kind of interested in how, is it like hash assembly or something like that?
No, it's not hash assembly. Let me use illustration from the website of ours. It will help us to understand how does it work. So as you can see here, and that's something that is very important to emphasize. So the encryption keys that are being used in order to encrypt the secret, those are distributed. The secret itself is not distributed, rather than the encryption key that is being used in order to encrypt the secret, okay? So it's kind of a hierarchy. So let's talk about the encryption keys. So the way that we do that, we are creating fragments on different regions, on different cloud providers. This, as you can see here in the illustration in front of you. Okay, so by the way, we're totally agnostic to the number of fragments, but for the sake of the illustration and the demonstration, this is three different fragments that are created as such. With Shamir secret sharing, you need to create a key and then to split it, okay? And then when you need to use it, you are connecting those fragments all together. With our solution, with our technology, those fragments are being created as such, okay? They are totally independent. Now, whenever on the client side, let me see if we have an illustration for that. No, but imagine that there is a client side, there is an SDK that wishes to, you know what, wishes to sign something. Okay, let's go step by step on that. So whenever the, and let's say that the key itself is an RSA private key, okay? So you have 3 fragments and another 4th fragments locally on your side, okay? And there's an SDK that is signing a certain document, okay? So allegedly, you'll need to have all of the fragments together, combine them into a private key of yours, and then to be able to sign the document, right? Okay, so that's allegedly. As a fact, what you need with the Akeyless DFC, distributed fragments cryptography technology, the SDK itself would create a hash for that certain document. That's the first step, right, with digital signature. The hash would be sent to each one of those node environments that hold that fragment, okay? Those are multi-region environments that replicate fragments between them, okay? And the response would be from each one of those nodes would be sub-signature of that particular fragment. So eventually you're getting sub-signatures that are being sent back to the SDK. Those sub-signatures are united to the final signature process, just as like the private key was on the client side, but it was never there, okay? So it is all using standard cryptography and standard mathematics, okay, in order to enable the process without combining the fragments.
Interesting, interesting. I had not foreseen sending the hash of the signed document to the, what are basically authorities, right? And the authorities are saying, okay, I'm going to mark this as a signed document, and then they're assembled with the authority of all of these sub keys, right? And then signed with the master key.
Exactly. Those are fragments of your private key, okay? And you mentioned the word authority, but it's important to say when we talk about RSA and PKI, etc., this is regardless of the certificate authority or the CA, the certificate authority for the public key and the validation process. This is in part of that process. We have now talked about the process of signing something. The validation of that is being made with the public key, which is public out there and is related to the certificate authority and so on and so forth. Okay, so we have now discussed about the way to sign with the private key without having the private key assembled at any stage, at any step of what we've done.
I could go very deep with you on this. I love learning more about this.
I'm free up to the morning time.
Hey man, I gotta feed my pets, but other than that, I got nothing going on. So let's see. Garish has one last question to close out our webinar. What kind of use cases do you see in regulated markets, specifically PCI and national defense?
Oh, that's a very good question. So everything needs to be hardened. Everything needs to be audited. So the use cases are quite honestly the same at the same markets, but the requirements of the hardening are different. So for that sense, everyone wishes to manage secrets for Kubernetes. Everyone wishes to manage secrets for Jenkins and Chef. Okay, Chef is strong with those markets, by the way. Puppet, Ansible, and all of those. So everyone has those DevOps tools. The thing with highly regulated environments is that they would more insist to have just-in-time access. So just-in-time secrets, the ones that are created immediately, because they have more concerns about the discovery of those secrets. And number two, the audit of the actions. So we talked about auditing SSH access when you're eliminating SSH keys. So they are more interested with those kind of solutions to completely eliminate the use of SSH keys, because as you know, SSH keys are a great hassle. Sometimes those keys are being shared, they're being forgotten. No one really remembers where your public key is. It's spread all around your environment with lots of Linux servers and so on. So they are more concerned about the privileged access, the zero trust access, and those kind of use cases. So audit, who entered what, session recording, just-in-time secrets, those kind of things. This would be, in a nutshell, the answer to your question.
Okay.
Chuck, back to you.
Okay,
Yeah.
that's good. That's a good answer. I apologize. I've got a couple. I need to turn my phone off. Goodness. That brings us to 6 o'clock. Jesse did have a quick question on if there's a paper or on the shared crypto system. Jesse, if you would like to get an answer to that question, I encourage you to reach out to Oded at his email address. You can see it there on the screen. It's oded@akeyless.io. And I'm going to be putting that in the chat here in just a second. Oded, I want to thank you so much for your time and for talking about problems that I'm sure are very relevant to all of us in our professional careers. This has been very illuminating and very educational. Thank you.
Thank you very much for the opportunity. I had a great time and I hope to have it again. And thank you, Chuck, for inviting us. And thank you all for asking those great questions. And I'm here whenever you have any questions to further on. We'll be happy to demonstrate it to anyone who is interested.
Fantastic. All right. Take care, everyone, and enjoy your evening and enjoy your mornings as well.
Cheers. Take care. Bye-bye.